I'm Kevin Elmy. In this presentation, we're going to be talking about plant ecology succession, what plants are growing and why. When we observe nature, nature has a beautiful system designed because when we look at a native stand of plants, we see lots of plant diversity. We see that that soil is covered. We don't see any nutrient deficiencies, and we don't see any other serious issues like disease outbreaks. When nature is left alone, there is a progression of plant types and soil development. Most of the soils are developed from parent material or rock. On that rock, we'll get some fungi and bacteria. They will go to work and they'll start creating very primitive soils, and this is where the lichens and the mosses start kicking in. As they progress and break down that rock to create more developed soil, this is where our weeds and our broadleaf plants start taking hold. As it develops further, our grasses and legumes start to dominate. After that, as it progresses, we start seeing more shrubs and bushes. Then we see trees as the apex vegetation type. So, looking at a slide on the left, we see our annual weeds, so a relatively primitive soil, and on the right, where we see our apex vegetation, we see our trees. So, as we move along, this is what will happen in our soil and plant ecology. When European settlers came to Western Canada, we were dealing with somewhere in that perennial weed and grass and shrubs kind of area. And what would happen is the bison and the antelope and deer would go through and they would graze as they were moving. The predators would keep the animals moving so they wouldn't camp out in one spot, and that would keep the vegetation fairly consistent. If it turned out that the shrubs became too prominent, there would be a lightning strike, and they would burn the soil to then move that soil plant ecology backwards a little bit. When the settlers settled and we started creating roads and railways, that acted as natural fire breaks. And this is why we started seeing the aspen bluffs starting to develop in the black soil zone. And then if left to continue on, would continue on into pine and spruce. But that is how the soils and the plant ecology go hand in hand. So what changes to allow different plants to grow? As we have these different successional plants growing, they will have different root exudates. The different root exudates are going to help stimulate different types of soil microbes in our soils and allow them to thrive. As we move from left to right in that chart, what we'll see is as we have these higher successional plants, they'll need more and more fungal component in the soils to allow them to grow. So when we see this slide again, now we have the annual weeds, and underneath it, you'll see that it says that they're bacterially dominated soils. On the right hand side, when we're dealing with a mature forest, those soils are going to be fungal dominated soils. So we'll dive into the microbiology just a little bit. They're better people better suited to talk about each one of these. It could be an hour talk on each one of these subsets of soil microbes. So as a quick rundown, your bacteria, they utilize the easy to digest carbon compounds in the soil. When given the right conditions, they will multiply very quickly in the soil, building up their population, and they will cycle nutrients in that soil very quickly. When we take a look at this sheath on the right hand side in the picture, and you'll see this root, and you'll see the soil stuck to it. What's happening here is the start of soil aggregation. So that living root will give off root exudates that will attract these microbes to that rhizosphere area. And the bacteria, they have their food, now they need shelter. And so what they'll do is they'll give off these glues and stickers in that soil and start soil aggregation. So bacteria are important from from the soil aggregation standpoint for the start. When we look at fungi, fungi will utilize more complex carbon compounds. They are too slow growing to use much of the easily digested carbon compounds on the soil because the bacteria are going to get them first. If they have the opportunity in a low bacterial soil, they will use these shorter chains. But their claim to fame is to utilize the complex carbon compounds like lignin, break them down. They're very slow growing, very sensitive to disturbance and change. They are very nutrient dense, so they are an excellent food source in that soil. And you can see, in once again the picture, you can see all the hyphae in the soil. It's going to act as extra roots for that plant root, assuming it's mycorrhizal, and get more nutrients for it. If it's saprophytic, it'll be breaking down nutrients in the soil of those long complex carbon chains. Uh, Wonderful things. We need to build the fungal component in our soils. And then above those, the bacteria and the fungi, there we have our predators. So our nematodes, our protozoa, our arthropods, things like that, they're going to eat the bacteria and the fungi. And because of the carbon nitrogen ratio in the way this food web is set up, this is how our nutrient cycles actually come to be. So we need those bacteria and fungi to be consumed in order to release those nutrients. Without those predators, we do not have a nutrient cycle. And when we look at the soil food web, we look at this slide and there's a lot of arrows, uh, really confusing. And this is probably very simplified because what we know about the soil is very limited. But this is the nuts and bolts of it. And one of the things just to mention is when we have a nutrient deficiency, one of the reasons, unless our soil has been completely eroded of it, when we have a nutrient deficiency, and most of the time we have ample supply in the soil, but we have one of these or multiple one of these arrows that are broken, and we need to refix those broken arrows. One of the ways to measure soil health is to measure the fungal bacterial ratio. And this is an estimate of the weight of the fungal and bacterial populations in the soil. The higher the ratio indicates higher successional soils and plants. The actual amounts in those ratios is still important because we need to know, are we dealing with 1 pound and 1 pound of fungal and bacterial, or are we dealing with 100 pounds and 100 pounds? So, the ratio is good. To know the actual number is even better. And we also need to ensure that we have diversity of those microbes in our soils. Having that diversity is going to, just extend the the soil health for us. One of the slides that I really like looking at and picturing in my mind when I'm talking to producers about soil health is this one. And basically it shows the pathway with some representative numbers of what they're estimating, what stage what is happening. So when we have bare parent material, so we're dealing with a highly bacterial soil, from there we start getting some fungi starting to come in and create soil. When we get to a fungal bacteria ratio of zero point 0.1, this is where we see a lot of these weeds, and that's wild oats, cleavers, things like that, those nitrate accumulators. Because when you're dealing with a high bacterial soil, what you're going to find is you're going to have a high nitrate count in those soils. You'll see a relatively uh, low kind of exchange capacity of your calciums. You'll see harder soils, but the weeds are the number one thing, especially the nitrate accumulators. Because once we start getting more fungi in our soils and we get to that zero point 0.3 fungal to bacterial ratio, a lot of those weeds, those early successional plants, they start to disappear fairly quickly. So then we see our bromes, our grasses, Bermuda grass. When we get to 0.75, we'll see the mid grasses, clovers, vegetables. Um, I like doing an estimate of about zero point 0.5 to zero point 0.6 of fungal to bacteria ratio of when sisal milk vetch starts kicking in. If anybody has ever tried growing sisal milk vetch, when we get to a fungal bacteria ratio of 1 to 1, so your late successional grasses, your row crops, native plants, when we get over that 1 to 1, this is when we start seeing shrubs and bushes start kicking in, and 5 to 1 to 101, your deciduous trees. And when we get into the 100 to 1 and over, that's when we start getting into the conifers and those type of trees. As cash crop producers, in my experience, I like to be between zero point 0.3 and zero point 0.8 fungal to bacteria ratio. This is high enough that you have enough fungi in that soil that you're not going to be having these high nitrate flushes, which is going to cause weeds. You have a system that's working fairly well. So by having a higher fungal to bacteria ratio, the early successional plants that need that nitrate or utilize the nitrate, they don't have that nitrate, so they don't show up. And those early successional plants, we call them weeds. So in the picture that it's on the screen, this is one of my fields that I seeded down to a cover crop with a perennial forage into it. And it turned out this year, seeded it, and we had no rain. So we were dry going into the spring, seeded it anyways. And because we didn't have active plants growing, but my microbial activity in the soil was still going, I had to start a buildup of some nitrates. With those nitrates, that triggered the weeds to grow. And I could have gone in, I could have sprayed it, I could have worked it, I could have done a lot of things, but all that would have done is move my fungal bacteria ratio down, which is going to encourage more weeds. So what I did is I took a breath and said, okay, leave nature and it'll go. And I'll show you what happened later in the summer when we did get a shower. Once our fungal bacteria ratio gets over zero point 0.3, those weeds, those early successional plants, start to disappear, at least the nitrate loving ones. When we start talking about thistles and quackgrass, that's a different story, different indication. This is that same field that was taken about two months later. You can see that those weeds have disappeared, and my cover crop and my perennial plants started growing. So Mother Nature took care of it without me having to go in and mess it up. When we have a fungal bacteria ratio over 1.0 or 1 to 1, we usually start seeing plant productivity start to decline. And that's normally because when we go into a management where we're not fostering that bacteria to grow and thrive, our nutrient cycle starts slowing down. And that's the reason why when converting to zero till, the land becomes sluggish for the first 3 to 5 years, depending on rotation, depending on quite a few variables. But most people, when they go to zero till, they say that their fertilizer requirements increase for the first 5 years, and then after that they back off. And that's the reason is because our bacteria levels, because we're not tilling anymore, we're not promoting that bacterial load. This also means that when we are planting trees, if you remember that a tree wants to be above 2 to 1 fungal to bacteria ratio. So when we have nice black soil with no weeds, because we've worked it intensively, that means we're going to be about a 0.3. When we do that, what's going to happen is we're going to see a lot of mortality in our trees. So when we have, a low fungal bacteria ratio and we're trying to establish trees, go to an area with trees, grab some soil, dig your hole where you're going to plant your tree, put that soil that you transplanted from underneath an established tree, and this way that tree is going to, when you put the roots into it, it's going to think it's in the right conditions to grow, and so it should have better establishment. So the farm management influences your fungal to bacteria ratio. So when we deal with tillage and adding fertilizer, that tends to decrease the fungi in your soil, but increases your bacteria. Insecticides and herbicides normally decreases your fungi, normally increases your bacteria. But there's some caveats against that. When we start talking about fungicides, it really decreases the fungi, both on the plant, and if it's systemic fungicide, it'll go into the roots and get into the rhizosphere, and it's going to fry the fungi in the soil. Uh, when I said earlier about the caveat against, you know, some of the things that will increase the bacteria, glyphosate has a patent as an microbial or an antibiotic that in 2003, so that when we over apply glyphosate and overuse glyphosate, this is one of the things that is a bit of an issue with it. So some of the plant effects, when we start dealing with plant residues, now we're going to be talking about some of the carbon to nitrogen ratios. And what I mean by that is, basically it's kind of a reflected back into the protein of that residue. So if we have a tight carbon to nitrogen ratio, so that means we have a, a moderate amount of carbon, but we have a fairly high amount of nitrogen. So in this picture, this is the some brassicas that are going to be growing, and they're relatively short, so they're going to rot quick. When they rot quick, they're going to cycle those nutrients quicker, and that tends to promote more bacterial growth. When we start dealing with a wide carbon to nitrogen ratio, so low protein, so a lot of carbon and a little bit of nitrogen, that residue is going to rot slower. So that's going to give us that soil armor. It's going to cycle nutrients slower. So that's going to tie up some of those nutrients, but it's also going to help promote some fungal growth. So growing crops and supplying high levels of fertilizer, given that you're going to be doing a lot of tillage also, and the use of a lot of biocides in your management, will create an environment supporting bacteria, so a low fungal to bacteria ratio. And one of the ways to look at it is a bacterial dominant soil is going to be addicted to inputs. So once again, we want to get away from inputs. We have to build that fungi in that soil. And once again, just to reiterate, when we start getting into the farming, the cash cropping, to be between that zero 0.3 and zero 0.6, nice place to be. Maybe be up to zero 0.8. When we deal with forages, maybe want to be in a little higher than that. But we want to make sure we don't get too far, so that we don't start seeing shrubs, unless that's what the goal is. So we'll do a bit of a case study. So we're going to be taking some cropland and we're going to seed it down to forage. So if we look at a typical land of cash crop land, and we're assuming that the fungal to bacteria ratio is around 0.2, so we're going to be seeding down a diverse forage blend with a nurse cover crop, and we have the option of taking that nurse crop off as a hay crop. So in year 2, we're not going to add any fertilizer, we're not going to do tillage, we're not going to use any biocides, and what will happen is, because we haven't disturbed it, we're going to build more fungi in that soil. That fungi now it's going to move our ratio up to 0.3 or 0.4. By doing that, what's going to happen is in year 2, we will see very few weld outs. We'll see very few cleavers. In year 3, once again, no fertilizer, no tillage, no biocides, whether you cut or grazed, we're still going to be building fungi in that soil. So now we're going to get into that 0.5 to 0.6. In year 4, no fertilizer, no tillage, no biocides, cut or grazed, our fungal to bacteria ratio is going to be bumped up again to the 0.7, 0.8. When we have a forage stand, eventually it gets, in quotes, tired, and productivity starts dropping. We may start seeing rose bushes. We may be seeing, some other shrubs starting to move in, or we'll go in, we'll add fertilizer, and we'll see a response in our production. What do we do? Well, that tells me that we have now crossed that 1-to-1 ratio of fungal to bacteria, and now we're going to have to do some management. Once again, when we talk about that ratio of being over 1 to 1, what is important is that absolute number in the fungal and bacterial weights. So are we talking about 5 pounds and 5 pounds? Or are we talking 500 pounds and 500 pounds? When we have something that is a 5 to 5, that's going to be less productive than something with more microbes. So the higher microbes has that ability to cycle more nutrients. The other thing about that 5 to 5 ratio is we can see dramatic changes in a short period of time. So if we have, we do some management, and we add that fertilizer, and that fertilizer is going to stimulate your bacteria in your soil. So now we can double that number of the bacteria. So we go from a 5 to 5 to a 5 to 10. Boom! You see this huge response. Other ways we can be dealing with this to help boost that bacteria is we go break it up because it's tired. So with the tillage, fertilizer, herbicides, that all reduces that fungal component in your soil, and increases your bacteria. So that balances out, gets you down into that 0.6, depending on how intensive you get. But as long as that fungal to bacteria ratio stays over zero point 0.3, those early successional plants will not appear. Once you drop below zero point 0.3, wall-oats and cleavers start to appear. The more intense and the longer the duration of the bacterial feed, the quicker that fungal to bacterial ratio uh, falls. So the more tillage you do, the more fertilizer and manure, the more biocides, the more bacterial growth you get, and the more fungal damage is going to happen. So how do we manage around this? So we have this field that we want to, it's tired. We want to take it out. Or we just want to put it back into a cropping rotation. How do we keep supporting that fungal to bacteria ratio? And some of the ways we can do it is intercropping is a real good way. But when we're doing this intercropping, we want to use fungal friendly crops. We can use relay cover cropping, once again, using this fungal friendly crops. And so the intercropping, I differentiate between the relay cropping, is the intercropping will be growing 2 or more cash crops together to harvest. This way, growing something like canola or mustard, we can grow something like peas with it, or lentils, so that this way, because your brassicas are non-mycorrhizal, we can have a mycorrhizal plant like a legume growing with it to help support that. Relay cover cropping is growing a cash crop and introducing another crop in with it, so that we'll harvest our cash crop and allow that relay cover crop to continue growing into the fall, into the freeze up, maybe overwintering, depending what your goals are. The other one we can work on to support the fungal bacteria ratio is reducing the amount of tillage we do. And we need to keep a living root in that soil for as many days as we can. That is crucial because, once again, the only way we feed our soil microbes is the best way is root exudates. So our mycorrhizal fungal friendly crops. This is something where, as we start looking at, which ones are friendly, which ones aren't, the quick rundown is your flax, sunflowers, forbs, legumes, minus the lupin, your warm season grasses, and your cool season grasses, in particular your oats, barley, and your ryegrasses. Those are the ones that are going to rely heavily on your mycorrhizal fungi. When we deal with rye, when we're dealing with the brassicas, beets, things like that, they're less reliant and maybe a zero reliant on mycorrhizal fungal. So we need to, when we looking at rotation, when we're looking at what plants are growing and what mixes we're doing, these are the things we need to look at. So the more we have these mycorrhizal fungal friendly crops that we're growing, the better we're going to be helping out that soil. One of the quotes that I really like, I was reading the Call of the Reed Warbler, and the Rodale Institute emphasized that that farming should become, once again, a knowledge intensive enterprise rather than a chemical and capital intensive or technological driven one. I think that's huge. And we're at the tipping point of getting getting too much into the technology and the capital and the chemical. We have to learn some of the old time agronomy. Hope you enjoyed it. And if you have any questions, you can contact us and we'll try and help out.